it becomes easier. But when the system becomes complex and the complexity goes on increasing, in that condition, it becomes very difficult to analyze with the normal method that we are going to study in the presentation. If you just see the presentation, I'll just show you. Now just see here. What are we going to study? Remember, this is unit number 2, part A, that is block diagram and signal flow, and that we are going to study. In this chapter, we will be studying regarding what are the basics of block diagram. Then there are some rules of block diagrams in order to solve it, examples pertaining to the block diagram, and similarly we have signal flow graph, and those we are going to study. Now, what exactly is block diagram and what are we going to study, that we'll just observe here. I hope the screen is visible to everybody. Presentation is visible. Presentation is visible to everybody.
Yes, sir. Yes, sir.
Okay. Now, see here. Important thing is, if you just observe the presentation and this, see here. Now, this was a simple mechanical system where we had a spring, we had a damper, and a mass. So, writing this in terms of mathematical equation, we had written it. We have already studied it, how to write it. That is, f of t is equal to, where is nothing but a simple force is applied onto the mass. There is a small displacement of x. Then correspondingly, we know that for mass we have acceleration term. Then for a damper we have velocity term, and for spring we have a displacement term. So this is the equation we have written. Then if the same equation is taken as a Laplace transform, we get f of s is equal to this. Then Laplace transform of that is x of s divided by f of s is this. Now, what is going to happen is, this is nothing but the transfer function of this entire system. It is a very simple system. So what we do is, henceforth in this chapter, the transfer function whatever you are going to get for the system is going to be represented by g of s, and that is put up in a block. So what I do is, I do not worry about what is there in the system. Instead, this is represented by a block. Remember, in block diagram, maybe a simple mechanical system or a very complex mechanical system is going to be represented by a block. Inside that block, if there is a g of s, remember that is the transfer function of this entire system. Got it? Is it clear? Okay. So with this, we'll go ahead with this. So when a force of x is applied, we are going to get a displacement. So this is the transfer function. So this is for a simple system. But remember, if the system is very complex, as in case of aeroplane, there will be a large number of sub-assemblies, and sub-assemblies put together, we have a large assembly. And this large assembly is going to work, and it is going to deliver some kind of action. As in this case, what is the delivery? It is transportation of passengers or nothing but the goods from one point to another with safety. So that is our basic idea of this. So there are nothing but so many inputs which are coming, and what is the output? Safe travel from one point to another. So this entire complex system, in the previous example, which was a very simple mechanical system, now replaced by a very complex system. If you just see, this entire thing is going to be replaced by only these three terms, that is input, block diagram, output, and which are interconnected by the sign. The same thing here. We have an input f of s, we have a transfer function of this, and with this is the output of the aeroplane. So remember, in this block diagram, we are going to see that the entire complex system are replaced by a block diagram, and inside we are going to have a transfer function. Now, as we saw in the introductory lecture, a subsystem can be represented by an input, output, and a transfer. That is what is written here. We can represent a system with help of block diagram and input, output, signal. That is what is done. Now, what is the definition of block diagram? Remember, definition of block diagram, this is very simple. Block diagram is a shortened graphical representation of physical system. I'm reading the second second definition, then I'll come to the first definition. It is a physical diagram of, sorry, one minute. It is a physical diagram of shortened graphical representation of a physical system, illustrating the functional relationship and its components. Means what? Whatever is the function, what are the relationship, everything is going to be represented by a block. We are only worried about what is the input, what is the output, and the entire system is going to be represented by the block. So similarly, if I take slightly more precise definition, it is a diagram of a system in which principal parts or the function. Now remember, block diagram need not be only a physical system, it can be a functions also. So it is principal parts or the functions are represented by a block connected by lines. So if you just see here, if you just see in the drawing, it is nothing but a block which are connected by the lines, and we have two input and output signal, which is and show the relationship between the blocks. They are heavily used in electrical hardwares, electronic design, software design, and other things. So block diagram, you all seen that for even during your when you are initially studying your computers, they're also used to draw the block diagram of a computer. Similarly here, for a block diagram of a system, we are going to only show this block. Whatever is there inside internal parts, we are not worried. We are only worried about the what is the input, what is the output, and how we are going to have the transfer function. That is what is the block diagram. Then next, why block diagram should be studied? Basically, the objective is to provide an understanding of signal flows in the system. Means how is the signal input is coming to the system, and once the system goes into the system, input goes into the system, how it gets interacted and how are I going to get the output. I'm only worried about the input signal and the output signal and how it is the interaction. I'm not worried about what are the interactions which are happening inside the system, because if it is a very simple system, we are understanding, but if it is a very complex system, then you usually get lost in understanding those internal parts. So here block diagram will tell you to provide the input signal and the output signal. Then to enable the modeling of a complex system for a simple building block. Means what? If we have a very complex system, you waste your time in understanding the internal architecture of that block. Instead, what we worried, I give the input signal, the input signal passes through the block, it gets processed, and we get the output. That is our basic idea. Got it? Then allows us to generate the overall system transfer function. Means all, it will help us to generate the overall transfer function of the system. Means what? If you just see, if inside there are three systems, so each transfer functions are further gets added up, and we have overall transfer function. So here it will become the overall transfer function of the entire system. It is not giving the transfer function of the individual subsystems which are there in the system. Example, if I consider this aeroplane, there are large number of subsystems. So each system will have its own transfer function, but I'm not worried about that. I want what is the entire transfer function of this system. That is what is going to get in the block diagram. In block diagram we give, it helps us to generate the overall transfer function of the system. It will not give the transfer function of the individual systems. Then there are few rules how to system. If the block diagram is very complex, example, you can have a block diagram of a petroleum product or a gas station also. In that condition, how this block diagram is going to help, we are going to get answer. That is also clearly understood with this. So there are few rules by which you are going to understand how this transfer this is going to happen. Now, okay, with this initial part, the bit of introduction is done. Do you have any queries or any doubts up to now? If you have any queries or doubts, let me know. I'll clarify, then we'll go to the next part. Are there any doubts? You can just put it in the chat box if there are any doubts, or else if there are no doubts, you can put no. So that will go to the next part. Anybody can? Okay. So what we'll do is we'll go to the next part. So block diagram, we understood why, what is the block diagram, what are the basic requisites, and now we'll understand the elements of the block diagram. Now, what I want is everybody to carefully observe this. In case if you have a pen and pencil, it will be used today or tomorrow. So please have a pen, pencil, or this with you, so that it will be helpful for you, and a book. Now, what are the basic components of block diagram? So as you had seen, there are few basic elements. What are those? We'll understand. So the basic block diagram have these four important components. One are the signals. What are signals? Either it is an input signal or output signal. Then second is a block. It can be in some books they refer as system. In some book it is referred as a block. Got it? So don't get confused. If it is written as system diagram in some books or block diagram, it is one and same. It is going the overall simplified version of that system. Then summing junction and takeoff point. What are those? That will just, we have not seen it. That will just see it. Only we have seen this. What are the input signal and block? What are the summing points and this takeoff point? That will just see. No, just here. Now here, what are the basic things? As in the first case, the first are the signals. So R of S and C of S. R of S, remember, henceforth in our block diagram problem, R of S is going to be represented as the input signal. R of S is going to be represented as the input signal, and C of S is going to be represented as the output signal. Just as in this case of here, we have R of S as the input, C of S as the output, and system G of S is going to represent the transfer function of this entire system. So as in the previous case, what are the important four components? One is signal and second is the block. So signals are these two. We have a block or the system. So here again, it is represented as system, and sometimes it is represented block. Most of the cases, it is block diagram. In some books, they write a system. Don't get confused. So this is the input signal, this is the output signal, and this is the block. Then the third one is the summing point and the pick-off point or the take-off point. Now we'll just concentrate on the summing point. What do we mean by summing point? Summing point is nothing but addition of arithmetic addition of the signals which are coming into a block. Now what is going to happen is, just imagine this is one junction. This is, as it is called as a summing point, it is called as a junction where a large number of input signal are coming. When this signal come, they get arithmetically added. What do you mean arithmetically added? Depending upon the signal, whatever the signal they have the sign, it is only get arithmetically added. As in this case, R1 of S is positive, R2 of S is positive, and R3 of S is negative. So they only get arithmetically added. So this is the input signal, and the output of this is nothing but C of S. So henceforth, remember, whenever there is summing point, the signal which are coming inside the system, they get arithmetically added. Now, in our problems, we'll have maximum 3 signals only. We'll have, this is one signal, this will be second signal, and third signal. Totally, there will be only 3 signals. Problems are there in our analysis or problems. So remember, in summing point, it is nothing but a point where the inputs or the signals which are coming, they get arithmetically added and they get mixed up. Then what is a pick-off point? Now here, this is a very nice concept. What is pick-off point, or also called a take-off point? Remember, there is one input signal, and I want this input signal to be same to all the example I give. Suppose he is one representative of, he is one of the representatives, and there are 3 classes, class A, class B, and class C. So, or division, I suppose, division A, division B, and division B. So for all 3 divisions, there is one representative, and whatever information he has got from the higher ups, suppose HOD or some class teacher has given some information to the leader to just give this information to all the 3 divisions. So what we want is, we want the same input. So takeoff point or the pick-off point is nothing but a point where the same input is given to all the branches. Just observe here, the same input, whatever is getting, it gets bifurcated into all branches, and it goes. Here, the intensity of the things will not change. Here, the intensity should not change. The same thing is even in case of electrical poles also. If you have electrical poles around, the KEB supply, whatever is there, or HESCOM supply, the same input is coming to all houses. There will be no change. So this is what. So there is one pole or nothing but one line. From that line, if I connect at 3 different points, so these are nothing but the signals which are coming for this. So that point is called as a pick-off point. Pick-off point is nothing but the point where the signal gets it gets bifurcated, but the intensity or the value does not change. Whereas in case of summing point, the input signals whatever are coming, they get added up. So these are the 4 important components of this block diagram. So first one is the signals, that is R of S and C of S are nothing but the signals. In second case, it is a system, that is R of S and C of S, that is input output, and we have a system. Summing point is nothing but a point where the signals which are coming, they arithmetically get added up. And pick-off point, or also called as a take-off point, is a point where the input gets divided, but without changing the intensity. It gets divided into number of points depending upon the number of outlets. As in this case, there are 3 outlets or 3 points. The same gets distributed into these points. Okay, here I'll just stop. Any doubts? Any doubts pertaining to this? Do you have any doubts pertaining to these components? Any doubts?
No, sir.
Okay. See, basically what we want is everybody to understand. So after a few slides, I'll just stop and ask. I want everybody to answer. Okay. Then once this is done, we'll go to the next point. Now, here, if you just observe, the operation of addition and subtraction have a special representation. So operation of addition and subtraction, as in this case I told, this is a summing point. Here operation of addition, here operation of the subtraction has a special representation. Means what? Here the signal is coming into the point, depending upon the arithmetic value, that is x plus y is coming out. Here there is one value, that is x, and there is y, so it is by x minus y. Now as in this case, here there is a x, there is y, and this is z. So the output is x plus y plus z. So same thing, whatever we discussed in the previous slide, is represented here. So this is called as a summing point, and summing point is usually represented by a circle and a cross sign. Remember, this cross sign should not be outside, and this cross should be at 45 degree only. Don't draw at 90 degree here. Don't draw at 90 degree. It will be at 45. Suppose if I circle, I'll have to cross this, and that becomes my input signal. And remember, this line should not be out. So this is the representation. So block diagram becomes a circle called a summing point, where appropriate plus or minus sign associated with the signal entering, they get added up or arithmetically added up. Any number of input signals may entering in the summing point. Here they have told that any number, but for our analysis or for this, we have only 3 signals, because if it is more than that, for us it will become difficulty for analysis. So there will be only 3 signals which are coming. The output is algebraic sum of the inputs. It is an algebraic sum depending upon the signal, whatever is there, that gets it. Some books put a cross sign in the circle. So here, most of the condition they put a sign. In some books, it is represented by this. Don't get confused. Both representation are same. Both are summing points. Most of the books they put cross sign. Some of the books they don't put a cross sign. Don't get confused. So it is represented by the summing point only. Then what is the takeoff point? Just observe, this is some students get confused what is the takeoff point. I would spare a few minutes here for your analysis or understanding. Now, in order to have the same signal or variable to be input to more than one block or summing point, a takeoff point is used. Means what? If I want this input to be given, as I told in the previous, whatever the information is given by HOD to a class representative, the same information should go to all the students. Suppose in a class there are only 3 students, and this information is given to him, and at certain point he is going to give this information. So this becomes the takeoff point. So they are taking some information at some point. So that point where the information is given to everybody with same value without changing the intensity is called as a takeoff point. This can also be like this also. You can just see the information is going. There will be some takeoff point here and some takeoff point. It is not need not be. It is in the same direction. This can be in this direction also. So this is a takeoff point. Now, and remember, in the takeoff point, whatever the signal which is there, which is associated with this, that gets carried it. So if it is a positive sign, it is not shown. If it is a negative sign, the negative sign has to be shown for all. Got it? So remember, in case of takeoff point, whatever is the intensity or whatever is the value of the signal, that gets given, that is given to the further things. Then distributes the input signal undiminished to several output. Means what? Undiminished means what? The intensity or the value does not change. That is the important point. Remember. Otherwise, you might say that it will be x by 3. No, it is x. Here also it is x. Here also it is x. Whatever, because input was x. So we have positive x, and a positive x. Then this permits the signal to proceed unaltered along several different paths to several destinations. Means what? The same input signal unaltered gets diminished or gets to several destinations. So remember, this one is the takeoff point. Then now we'll be understanding few rules before going. I'll just spare. Okay, with this, the initial elements of the block diagram we have discussed, and now we'll be discussing few important rules. As till now, are there any doubts? Up to now, are there any doubts? Up to now, starting with definition of block diagram, then the components of block diagram. Are there any doubts?
No, sir.
Okay. So what I'll do is I will go to this rules. Now remember, here onwards we'll be discussing. There are 3-4 rules. So that you just observe. Now, first rule is called as a cascaded system. What is cascaded system? Any finite number of blocks in the series may be algebraically combined by multiplication of the transfer function. Means what? Just observe. There are 2 blocks which are in series. So there are 2 blocks which are in series. So in that condition, what I can do is I can simplify this entire thing by putting this rule that is called as a cascaded rule. What do you mean by this? So E is input. This is nothing but the multiplication which is going to happen between these two, and I am going to get G1 into G2 into C. So this is the one rule. So the output of this and the output of this is going to be multiplied, and this we have this. So if there are any 2 blocks which are in series, you can simplify them by multiplying and put that block in you can have a single block wherein you are going to only multiply the transfer function of both the thing. Do not worry about the signal, whatever is there. That gets means what, that is compensated by this, means what, whatever is the signal is there here, it comes here again once after multiplication, both are multiplying and we get this C. So this is, remember, and here just observe this, multiplication of transfer function is commutative. You know this rule. What is commutative? Nothing but G1 into G2. You can write G2 into G1, no problem. Even G1 first, G2 second, G2 first or G1 second, then can be written. That is what is here. Gi into Gj is equal to Gj into Gi. As in this case, G1 G2 is equal to G2 G1. You can write anyway. It is commutative function. So remember, this is the first rule where it is called as a cascading. If the blocks are in series, I can combine this and write a single block. I'll have to write the transfer function. I multiply this transfer function and write as a single block. So this is the first rule. That is called as a cascading rule. Then the second rule. Now same here, there are one more examples we have taken for your understanding. Suppose we have so many number of blocks. So how is this going to be? Just observe here. R of S, G1 of S, and I have one output, that is x2 of S. Remember, this is one of the function, that is x2 of S, which is equal to G1 of S into R of S. Just observe here. R of S into G1 of S is coming here, G1 of S into R of S. So this is the output. Now this output, which is coming from this block, becomes the input for this. So R of S into G of S was your input. Input was G of R of S, and transfer function of, hello, any confusion? Okay, see here, input was R of S, transfer function was G1 of S. So the output, whatever I'm going to get, that is equal to R of S into G of S, G1 of S. So the output, this output which is coming from this block becomes the input for the second block. So the input for this block, second block, is G1 of S into R of S. Then what should be the output here? It is simple, G1 of S into R of S into G2 of S. That is nothing but the output. So the output, whatever is there here, that becomes the input for the third block. So the input for this block is G1 of S, G2 of S into R of S. So the output will be G1 of S, G2 of S, and G3 of S into R of S. As I told, it is a commutative. You can write anywhere, no problem. So if this block is there, how I can write? You need not write this intermediate things. You can directly write R of S is nothing but equal to G1 of S, G2 of S, G3 of S, and C of S. So this is your input. This is your output. This is your output. So this is what is nothing but the equivalent transfer function of this entire cascaded block. Hope this point is clear. Any doubts? Is there any confusion for cascading? Yes, is there any confusion? Hope it is clear. Cascading block means if there are two blocks which are there in series, the transfer function gets multiplied. Hope this point is clear. Then what I'll do is, hey, tell me.
Sir, if the input signal is multiplied initially, sir, then why in the answer it is not?
No. What here we have not. This is a simplified version. Here output C of S nothing but equal to R of S into all these things. Understood?
But after first block, sir, G of S is multiplied with R of S, no, as the output signal to second block.
Correct.
So then why is it not written inside the block?
No. Here we have not written because in order to reduce the confusion. That's it. Got it. Nothing else. That is taken into consideration. Here G of S, what this input signal is there, is coming here. We do not write all the things inside, because basically what we do is, in order to simplification, that is a basic, the thing of block diagram. Here all the things which are there, which are increasing the complexity and confusion among the control engineers, that is basically reduced here. We do not write basically because it is taken into consideration here. Now as in this case here, we do not write this the signal, because once we go for this simplification, it is taken into consideration. That is what. So if there are three blocks, as in this previous example also you can see, if there are three blocks, I'm not worried about what is the intermediate signal which is coming, because after multiplication it is taken care by the thing. So we do not write intermediate signal into the block. We only multiply this, because after multiplication, this transfer function, whatever is there, it has taken care of intermediate signal which are coming through these blocks. Hope this point is clear. Is it clear?
Yes, sir.
Then similarly, next rule is the parallel rule. So the next rule is called as a parallel rule, a parallel form rule. Parallel form rule is nothing but if there are two blocks which are in parallel to one another. So as in this case, this R of S, there is one G of S which is one parallel. This is parallel. So it is coming through this. Then how it is going to be represented? You can just observe here. It is parallel form. I have taken the same example, slightly this. This is equal to G1 of S, G2 of S, and G3 of S. So here it is a takeoff point because the same information or the same input is given to three blocks, and we have the three input signals. We have three input signals which is coming to the takeoff point. So this takeoff point, it will be equal to x1 of S, x2 of S plus x3 of S, summation of all the three, that is represented like plus or minus G1 of S plus or minus G2 of S plus or minus G3 of S into R of S. You can just observe here. So in case of parallel form, it gets added, but in case of series, it gets multiplied. Remember, in cascading rule, if the blocks are in series, the information or the blocks are multiplied, but if they are in parallel, they get added up. This is the important thing. Just observe here. So only the important thing is, so the equivalent we are getting is, it is a summation of, so this is what is GE. GE is nothing but G equivalent, or you can write only G of S. So G of S is equal to summation of all the three blocks. So don't worry about this intermediate signals. Just observe this. I only write whatever is the transfer function of this. So it will be equal to G1 of S into R of S, G2 of S into R of S, G3 of S into R of S. So the equivalent will be G1 of S, G2 of S, G3 of S. So this becomes the transfer function of this. And the input signal and output signal are going to remain same. So this is the second form. So first was the cascaded effect. Second one was the parallel form. In a cascading form, if there are two blocks which are in series, the transfer function gets multiplied. In case of parallel form, if the series are in parallel, the transfer function gets arithmetically added. So this is the second form. Now we have the third, which is called as a feedback. Now, what in case of feedback, this is third form. Now, what is the feedback? Means what? I'll just give an example. Suppose you are driving two-wheeler and you are driving the two-wheeler, and suddenly you come across the traffic light. And you see that the green light is suddenly gone to red. You are closer to the traffic light, and suddenly the green light has gone to red. So the information from your mind or the brain in the form of pulse will go to your hand and also the leg. Suddenly you apply the clutch. Suppose you are riding a two-wheeler with a geared vehicle, you apply a clutch and you reduce the gear and you apply the brake. So this input signal is nothing but, depending upon the input signal, there will be some kind of feedback which is taken from this input signal and they are coming back. So what is the feedback form? Feedback is nothing but open signal which was there. If it is to be converted into a closed loop, I take a feedback from the input signal and I again rectify this input signal so that I control the entire process. So the feedback is nothing but the signal. It can be a positive feedback or it can be a negative feedback depending upon the action. We are going to take a certain feedback from the output signal. We are going to give it to the input, and this cycle continues till this system becomes stable. So that is nothing but the feedback. I'll just read here. The third form is a feedback form. Let us derive the transfer function. So how was this transfer function? If there is a feedback form or the loop which is of this nature, so how I'm going to have the transfer function? So how I'm going to get the transfer function, that we are going to study. Remember, feedback is only seen in a closed loop systems. It is not there in open loop. In closed loop system, input is there, output. From output there is certain kind of feedback, maybe positive or negative. It goes to input, again it gets rectified. So this system is called as a closed loop system. Now this is a typical feedback system which is same. So there is one R of S, then there is summing point. Why there is summing point? Because you have taken a feedback. Depending upon the feedback, whether I will have to reduce the intensity or increase the intensity, that is taken as per the feedback. Here, as in this case, we'll have to reduce there is something because it is a negative sign. So these gets added up and that becomes the input signal. So this will continue till this line becomes stable. this system is said to have negative feedback if the sign at the summing point is negative, and positive feedback if the sign is negative. Means what? The feedback signal can be either positive or negative. How to understand? Only just observe this sign here. If the sign is positive, it is called as a positive feedback signal. If the sign is negative, it is called as a negative feedback signal. Hope this point is clear. Remember, if the signal is positive, it is called as a positive feedback signal. If the signal is negative, it is called as a negative feedback signal. Then, this is an important derivation. Never asked, but you'll have to only observe this. I'll just explain this. What is the feedback form? As in the case of parallel form, we had added the transfer function. As in the case of cascaded form, we had multiplied. But in the case of feedback signal, there is some different thing. What is that we are going to study? It's here. Now just observe here. We have an input signal, that is G1 of S, and it is passing through. Don't worry about now. Presently, do not worry about the feedback. Only try to see that this is only the first thing. Just for just a moment, you do not consider this any feedback. Now, suppose this is the input signal. Then it goes to one block, it goes to another block, and we have output. But I convert this open loop to closed loop. So what I do here, there was an input transducer, we have a controller or plant, and we are getting output. Then I want to convert this to this. So what we do is, from the output we take one feedback. From this output we take a feedback. Here, see here, if you just observe here, there is plus or minus sign. Plus or minus sign means what? Sometimes this feedback can be positive, sometimes it can be negative. So we write both the sign. Depending upon this, if the signal at that point was positive, positive sign gets added up. If the sign was negative at that point, negative sign gets added up. So just observe here. So R of S passing through the summing point, it comes through the controller, it comes through the plant, and we have a signal that is C of S. So this output is taken, it is passing through the output transducer, feedback is given, and this is called the actuating or the error signal. Now, in this case, how are we going to write the transfer function? So remember, what is E of S? E of S is equal to R of S minus H of S and C of S. So this H of S, what is H of S? H of S, because here H1 of S and H2 of S, for our simplification, what we consider, this is H of S. So this is our feedback. So H of S is the feedback, H of S into C of S. So the output or the feedback, whatever you are going to get, that is nothing but equal to input minus this feedback signal. So why I have taken negative? In the present case, whichever is prominent is written on the top. Initially, which was the negative? If it is written plus or minus, then I will get plus here. But here it is written minus plus. So means what? The initial was negative. So it is written as R of S minus H of S into C of S. So this is the initial, my initial equation. But we know that C of S is equal to G of S into E of S, because we know that the output signal is equal to the input signal into transfer function. So C of S output is equal to the transfer function into input signal, that is written. So this is equation 1, this is equation 2. I slightly rearrange. So what I do is C of S is equal to G of S, I take in the denominator, and whatever was E of S, which was there in the equation 1, I have substituted here. Just observe here. This is the equation number 1. This is equation number 2. So I'll just once again repeat this. How did we get this initial equation? Because we know that actuating signal or the error signal is equal to input signal plus or minus the output signal into the transfer function of the block of the feedback. The transfer function of the feedback is H of S into the output signal. So R of S minus H of S into C of S. This is my input. This is the equation. Second equation, we know that output signal is equal to input signal into the transfer function of this block. So this what we have done is, for our simplification, we have written this as G of S, because it is G1 of S into G2 of S. So that we write as G of S. So this is G of S into E of S. Now, what I do is I slightly rearrange this. That is equal to E of S is equal to C of S divided by G of S. And what is E of S? From equation number 1, it is R of S minus H of S. So this is the equation number 3. This is equation number 3. Then what we do is, here C of S, just observe here. Then what we have done is, this is the equation. then we slightly this g of s is taken here and multiplied. G of s is taken multiplied here. So g of s into r of s minus h of s c of s into g of s. Just observe here this equation. C of s is equal to r of s into g of s minus h of s, c of s, and g of s. So this is what we have done. So in this case, c of s, so what I do, this negative term which are there, I shift it to that side. I shift it to that side. So r of s into g of s is one side. That is equal to c of s plus h of s into c of s. Since c of s is common, I have taken it outside. This is taken outside. So what I get is g of s into r of s is equal to 1 plus h of s into g of s into c of s. Got it? So here, but we know that what is the transfer function? It is nothing but Laplace transform of output by input. We know that transfer function is nothing but Laplace transform of output by input. That is equal to c of s by r of s is equal to g of s divided by 1 plus h of s into g of s. So this will be equal to 1 plus h of s into g of s. So this is nothing but the transfer function of the feedback form. Once again, I'll just repeat here. So if you just observe this carefully, just observe here. Please, everybody just observe. No one is going to ask the derivation, but this is important for your understanding. I'll just repeat it here. The error signal is equal to, it is the arithmetic sum of input minus the feedback. Input and feedback. If the feedback was positive, it becomes positive. If the feedback is negative, it is negative. In this case, it is negative. E of s is equal to r of s minus h of s. There is a transfer function of this block, feedback loop block, as well as the output signal that is written here. Then, but we know that output is equal to input into transfer function of this, that is written here. C of s is equal to g of s into e of s. But we know that e of s is equal to this. So what I do is I only transfer this or substitute this in equation number 1. This, so I get g of c of s, g of s I have taken in the numerator, that is equal to this term. Then what we do is we again multiply this. So c of s is equal to r of s into g of s, that is written here, minus h of s, c of s, and g of s. Then whichever c of s terms are there, I put it one side, and other terms I take it on another side. So what I have done, c of s term I have taken it onto the right hand side, and g of s into r of s I have taken it to left hand side. That is equal to c of s plus h of s, g of s, c of s. C of s is taken outside, but we know that the transfer function of any system is equal to output, Laplace transform of output divided by input. So that is what we have written. C of s divided by r of s is equal to g of s divided by 1 plus h of s into g of s. So this is the, so how to remember? Every time do we need to derive this? No, it is very simple. I'll just go back to this block diagram for your understanding. I'll just go back to the, I'll go back to this. How to understand? Remember, just try to observe this. Just try to observe this block. G of s, h of s, and this. Sure. Yes, 1 minute. Yes, yes. Tell me. Tell me.
Okay.
Any.
So how to whether feedback loop is positive or negative?
That I was telling. Just observe here. See here. You just try to see the prominent sign here. It is negative. Consider only this. Do not worry about these other things. Only just simplified version I have written. So r of s is positive. We have e of s as an input. This is g of s, c of s, this. So if I want to write this, how to write here? G of s divided by 1 plus. See, just observe here. G of s divided by, that is g of s divided by 1 opposite of this sign. 1 opposite of this sign. If it was plus minus, it is minus plus. As in this case, it is minus plus. We write plus minus. Got it? If it is negative here, I write positive. If it is positive here, I write negative. Got it? Just observe. Yes. Everybody, remember g of s divided by 1 opposite of this sign into this and this. This and this. G of s divided by 1 opposite of this sign into this transfer function and this transfer function. That is written here. As in this case, g of s divided by 1 opposite of this sign is nothing but it is minus plus, so it will be plus minus into g of s into h of s. That becomes the transfer function of this. Is it clear? Has it, whether it is understood? Any doubts? So,
No, sir.
is it clear? Understood?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So for everybody, just observe it is very simple. For a feedback loop, the transfer function is written as g of s, that is transfer function of this, divided by 1 opposite of this sign, this into this, that is written this. So this is the equivalent thing. Got it? Okay. So with this, what I'll do is I'll just stop here. You can take a break of 5-10 minutes. Then exactly at 11 o'clock, we'll start with the next part. So initially we have 4, 5 discussed, then we'll discuss the further part. Okay, you can take a break.
Okay, sir.
Shall I start the class or we'll wait for a few minutes? Okay, welcome back. We'll start with the class. Uh, so, a few minutes ago, we had understood the important rules, the three important rules what we had studied. One was the cascading form. Second one was the parallel form. Hope everybody's there. Shall we wait till 11 o'clock or we'll start? Hello? Okay. We'll okay. We'll start exactly at 11 o'clock. Okay. I will start with the class. So we had seen the cascading form, the parallel form, and the feedback form. The same thing is discussed here. You can just observe here. This is the for any feedback signal. This is what we write. That is C of s divided by R of s. That is equal to G of s divided by 1 plus G of s into into H of s. Now remember, in this, the denominator, just observe this, the denominator 1 plus or minus G of s into H of s is called as the characteristic equation. Just observe, everybody. Okay, I hope everybody are back. Okay, remember this. Henceforth, this is the important concept, not used now, but it will be used later. Remember the denominator 1, that is 1 plus or minus G of s into H of s is equal to 0. This is called as the characteristic equation of the system. This is called as a characteristic equation of the system. Just remember this. In this unit or next unit, we'll be using this characteristic equation. Okay, with this, I'll go ahead. Now, the same thing, the feedback form, how it is written here. If we have a form that is G, and we have a feedback form that is, we can write C divided by C of s or R of s. So in some books, what I read, they do not write that yes, because consider that is already in the Laplace transform form. So that is right, C by R is equal to G divided by 1, opposite sign of that is plus or minus G into H. So this is what. Now, see here, sometimes in some of the blocks, this H is not seen. So don't get confused. If H is not seen, it is considered that H is equal to 1. That is called as a unit feedback signal. Means the feedback, whatever is there, it is a unit. The value of that is 1. So this is going, if for this unit feedback, if I want to write, we write C by R is equal to G divided by 1 plus or minus G. So it will be, because H is equal to 1. So remember, for unit feedback signal, we write we write the transfer function as C by R is equal to G divided by 1 plus or minus G, because H is equal to 1. So don't get confused. If there is nothing written here, it will be considered as 1. Then the same thing, combining, we'll revise it once again quickly. So combining of the board, also called as a cascading, it is equal to G1 into G2. Then if it is parallel form, it will be G plus or minus. Now see here, just observe here. Now here I want to take out one query which student have. Just observe here. Now, how to observe whether a signal is a feedback signal or it is, or the block is in feedback or it is in parallel. Just observe this sign. If it is in opposite direction or it is coming back, it is a feedback. If this sign is in the front direction, as in this case, just observe here, as in this case, the signal is always in the forward direction only, then we can say that two blocks are in parallel. If this signal, as in the previous example, the signal is opposite or returning back, that becomes a feedback. Don't get confused. How to understand, if we have a point and the signal is in opposite direction, then that becomes the feedback signal. But if the signal is not returning back, but two blocks are connected to one another and the signal is moving forward, then we can say that both the blocks are in parallel to one another. So in this case, what will be the condition? It will be G1 plus G2. Because why? Here plus sign usually they don't write. If it is a negative sign, then only they write. So remember, if there is a positive sign, they do not mention. If there is a negative sign, they mention. So remember, in this, both the blocks are positive. So you write G1 plus G2 because it is in the parallel form. Here G1 and G2 both are positive, so it will be G1 into G2. Then, okay. Now here, till now, is there any confusion? Till now, are there any confusions pertaining to this? Because next two concepts are very important. I want everybody to carefully observe this. In case if you have a book, just stop doing anything, just concentrate here, because this is a very important concept. Once you understand, you will remember. If you do not understand, there will be a lot of confusion. Okay, now just observe this, which is the next rule. So the previous two rules are, if both the blocks, so we are understanding now rules of solving. So if you just observe here, block diagrams we understood. Now these are the rules. So cascading is the first rule, where if the two blocks are in series, we have multiplied. The second rule is the parallel. The third rule is this. What is the third rule? That we'll just observe. The third rule is moving a summing point behind a block. Moving a summing point, this is the block, moving the summing point behind the block means what? I am taking this block and I'm shifting it here. I'm shifting it to here. Just observe here. This block, if I take it and shift it here, so this is what it is called as moving the summing point behind of the block. No. In this condition, what are we going to have? Now, just observe here. Now, do not worry about what is happening here. Only observe here. Just observe here. So here we have a signal that is A. Here we have a signal that is minus B, which is coming and which is coming into the block. So the after summing, it will be A minus B. So here A minus B. So the output signal C is equal to G into A minus B. So the output signal which is coming here, it will be A into G minus B. So this is the present arrangement. In the present arrangement, we have two signals which are coming. That is, one is A, one is positive, and second one is B, which is negative. Both gets arithmetically added, that is equal to A minus B. It comes into block. So after multiplication, the output is equal to G of A minus G of B. So this is there. So, but what are we applying here? We are applying a rule where I am going to shift this summing point here onto the front. So this is nothing but this. So if this happens, then that condition, remember what, even if you shift, my output value should not change. Even if you make any arrangement, my output should not change. In that condition, I cannot directly keep the blocks like this. There has to be some modification which has to be done. Why? Because my output should not change. Now, just observe here. The signal which is coming here, it is G into A. So the output, the signal which is coming here is G into A. But the signal which is coming here, it has to be G into B. It has to be G into B, because the signal, output signal, is nothing but GA minus GB. But if this block is not multiplied, what I get? I get C into G of A minus B, which is not correct. Why? Because the output, whatever I want, it should be G of A minus G of B. So in this condition, when I take the summing point ahead of the block, the signal has to be multiplied by this transfer function which is there in this block. So remember, when I take a summing point behind the block, when I take the summing point behind the block, or I move in front here, in that condition, the signal whichever has been moved has to be multiplied by the transfer function of the block which we have moved. So if it was G1, it should be G1. If it is G2, it should be G2. So as in this case, it is G. So once I move this here, so this signal is multiplied with the block. Reason why? Because the output should be what? GA minus GB. But if this signal was not multiplied with the block, then what would I have got? C is equal to G into A minus B, which is not correct. Why? Because here GA minus GB should have been there. Here we would have got only GA minus B. But in order to have the constant output, same output, because we have only modified, output should not change. For this, so we should get GA minus GB. GA minus GB. Hope this point is clear. Is any confusion pertaining to this? Do you have any confusion pertaining to this present rule? Any confusion? Because here these rules are very important. If you have any doubts, please feel free to ask. Put it in the chat box, unmute your mic, get it clarified. Because this is very important. Because with this only we'll be solving the problems. And remember, on this chapter we will be solving, because on this chapter directly 10 to 15 mark questions are asked, and it is only solving of block diagram, and these rules are very important. So for that I'm asking. I'll explain. Okay, just observe here. Now see here the output of, so here what I want is, I am just solving this. So just observe, this is block A. So this is this input signal A, and this is the input signal B. So as we know that whenever it is interacting at the summing point, it should be algebraic sum of this. So it will be A minus B. So A minus B, and as it is passing through this block, this gets multiplied. So output C is equal to G into A minus B. G into A minus B. This is what is the condition. So what do I want is, I'll just move this block in front of this. So I move this summing point in front of this block. So when I'm doing this, just observe here, my output should not change. My output should remain G into A minus G into B. But if this block was not, because in this, if you just see this previous drawing, here block is not there. If block is not there, what would have been the answer? G of A minus B. But what I want G of B. So in that condition, when I move the summing point ahead of this, when I move this, so remember the signal has to be multiplied by this transfer function. So we get g of a minus g of b. So this is the rule. Hope this point is clear. Similarly, if the summing point is moved behind, if the summing point is moved here, if the summing point is moved here like this, so in this condition, how is this going to happen? Just observe here. It is g of a minus b, g of a minus b. This is the output. So if the summing point is shifted from in front, it is moved here. If it is moved here, so in that condition, what is going to have? We are going to have this. So a is here. So here I want g of, here I want only b. But here, if I take, what is going to happen? It will be g by b. But I don't want g by b. I want only b. In that condition, you'll have to divide by this 1 by g. So I get g of a into b. Just observe here. Whenever this summing point is taken back like this, in that condition, whenever it moves forward, it has to be multiplied. Whenever it is taken back, it has to be divided. Symbol. Whenever the summing point is moving here, front, it is multiplied. Whenever it is taken here, it is divided. It is divided. How to understand whether it is doing? So summing point, you are moving here in this condition, you are going ahead here, so it will be multiplied. Whenever you are going it behind, it is divided. Is it clear? Any doubts? Any doubts?
So why are there two signs, sir?
Which one? Tell me. Can you repeat the question?
Fourth diagram, sir. So fourth diagram, sir. Why are there two signs, sir, and how to use them?
This sign, no? This sign you are asking?
Yes, sir. Yes, sir.
This sign. No, see here. Here, sign is nothing but this sign only. No? Whatever the sign which this signal had, the same sign is here. Got it? The same sign is here.
Yes,
but
sir.
Only what is happening here, as you are moving, as you are taking this summing point behind here, we are moving here. In that condition, the output, if you just see here, C of A is equal to G of A minus B. This is correct. But if this is coming here, I'm getting G of A minus G of G divided by B. So, but I don't want G divided by B. I want only B. In that condition, this gets divided. Sorry, it will be B divided B by G. Not here. One minute. There is a mistake. What I have done. Just a second. No, it's correct. It's correct. It's correct.
So it should be B by G, sir.
No, it is not B by G. It is correct.
No, sir. Then it will become G square, no, sir.
1 minute. So the sign, 1 minute. Just a second.
B by G, sir.
No, it will be this. This bracket does not come. This bracket does not come. See, I'll just tell you how it is. Just a second. Give me. G into A minus G by B.
So bracket will be there, sir, and it should be B by G, sir.
It will be B by G. Correct. It will be B by G, not G by B. It will be B by G. Correct. Bracket is there. It will be B by G.
Yes, sir.
Not G by B. It will be B by G. Right. Now we are getting it. Correct. Okay. So it will be, just observe here. So it will be G into A minus B by G. So if you multiply here, it will be G into A minus B. So this is what. So remember, whenever we are taking the summing point, it will be multiplied. Whenever we are taking bit, it will be divided. Is it clear? Understood? Any doubts?
Sir, the sign, sir, you did not explain.
Sign is
so
only
which sign to consider, the positive or negative, sir?
No, whatever sign is there, that you will only have to consider. Here, negative sign is there, no? Got it. In this condition also, it is A minus B. Here also it is A minus B only.
So and what about the positive sign?
Which
so
one?
What does it apply?
No, positive sign only for positive sign. It is already taken into consideration. No, it is positive only. No, this G into A is positive only. Hope I'm clear. Any doubt?
We don't need to like operate it.
No need. And you are already taken into consideration. If the sign is not shown, it is considered as positive. Remember, if sign is not shown, as in the previous example also, it is not shown here. So it is considered that the sign is positive. But if it is shown, remember, most of the condition, if it is a negative sign, then only the sign is shown negative. If it is not shown, consider that sign, that signal will have positive sign only. That is what you remember.
Okay, sir.
Got it? Now, it's just important, remember this, because in takeoff point, opposite will be the condition. In takeoff point, opposite is the condition. Got it? So, if you just consider this, hope this point is clear. Hope these two things are clear. When I am taking the summing point ahead, so I multiply this. When we take behind, we are going to divide it. But here, in this case of takeoff point, just observe here. What is the condition? Here, output is G into A. Output is G into A, and that is coming as B. So the B, whatever is the output which is there, that should be equal to G into A. But remember here, I'm going to take a takeoff. I'm going to take a takeoff here. But what I want is B should be equal to G into A, B equal to into G into A. But if you just see this signal here, we don't have that block. So if I don't have that block, I cannot get G into A. I'm only getting A, but I don't want only A. I want G into A. So whenever this takeoff point is, this point is taken behind a block. Just observe here. Takeoff point is taken behind a block. When a takeoff point is taken behind a block, the block is multiplied by the transfer function. The block is multiplied by the transfer function. Hope this point is clear. Whenever this takeoff point is taken behind the block, how do you take behind the block? This was positive. This in this direction it is going. When I take, it is called as behind. So I'm taking it behind. When we are taking it behind a block, this signal is multiplied by the block. This block is multiplied. Just observe here. Because what was the output here? Output is B is equal to, or C, whatever. In the previous example we have taken C, but here we have taken B. B is equal to G into A, that is written here. So B is equal to G into A. But here, whenever I'm taking a takeoff, what I want is, I want the same output here, that is G into A. Because A is passing through G, it will be G into A. A is coming here, but I want G into A only here. Because as in the case of takeoff point we have seen, takeoff point is nothing but a point where the output will be same as that of the input without any change in the intensity. So if you just see here the same value, so here the output should be G into A, so the output should be G into A only here. Is it clear? Any doubt? Is it clear? Similarly, when we are taking the takeoff point ahead of the block, when I take this ahead of the block, just observe here. Here A, here I am getting A. Here I am getting A. A is here, A is here. What is the output here? It will B is equal to G into A. It is equal to G into A. But if you just see, when I'm taking this takeoff point here, here I'm getting B is equal to G into A. But here I want what? I want only A. So this B, which was equal to A into G, should be divided by G so that I get only value A. Got it? So what was B here? B was equal to G into A. But what I want only A. So this G has to go. So if I want to go out that G, I should divide by D. So B is equal to. So this is when with this takeoff point is taken ahead, this signal is multiplied by 1 divided by the transfer function of the block which you have moved. 1 divided by the transfer function which you have moved. Is it clear? Any doubts? Just please, because here these two things are very important. Summing point and takeoff point are very important. So if you want, you can just note it down for your clarification. Just note it down in one or the other page. Just note down this. Anyhow, this PPT will be shared with you, no problem. But at this point, if you want, just remember and take down this, or even you can take a click so that you can remember, because this is very important. Once again, you can just see in case of takeoff point, summing point, when you are moving, this has to be multiplied. When you are moving behind, it is to be divided. Opposite is a condition. When you are taking behind, it has to be multiplied. When you are taking ahead, it has to be divided. The opposite is a condition. So among these two, you remember one, opposite will have to do it for the another. Is it clear? Is it clear? Any doubts? I'm stopping here. I'm waiting for a few minutes. Go through this. If you have any doubt, let me know. So we'll understand. Is there any confusion? Any confusion pertaining to the summing point and takeoff point? Okay. As there are no, then what I'll do is I'll go ahead. Just observe. Then the same thing is eliminating the feedback, as in this case, G, and we have negative, so it will be G divided by 1 plus H. 1 plus, so it will be plus or minus, because here plus is not seen. So just consider this. Don't worry about the sign here. So here just feedback. It will be plus or minus. It will be minus plus. Plus or minus. It will be minus plus. So this is the condition. G divided by plus or minus. So it will be G divided by 1 minus of plus G into H. The same thing here, because it is a unit. G divided by 1 minus of plus, it will be G. So this is the for feedback loop as well as for unit loop. Now this is we have not discussed. This is the new one. Suppose there are two summing points like this. In that condition, you can replace the position. As in this case, if you see A, B is there, you can replace the B and A. So this is also feasible. This can also be done. Swapping the two neighboring summing points means what? A can be swapped here, B can be swapped here. But while doing it, take care of the sign. Take care of the sign. Whatever is B sign is there, you can swap it with proper sign only. You'll have to do. Only can swap the positions. This is also allowed. But remember, don't swap without changing the sign. If you make swap it and keep the previous sign, then there might be problem with respect to sign. Because consider, as in this case, if A was positive and B was negative, if you are swapping and you write B as positive and A as negative, then becomes confusion. Got it? So you can swap the position provided you take care of the signs. Okay. Now here the same thing, whatever we have discussed in the blocks, as a pictorially, this 4-5 slides are there where we have put the same thing in the blocks, where we have put the same things in terms of the table. The same thing are there here. Same things, whatever we have discussed. Once again, I'll just for everybody's benefit, I can repeat. So block diagram, if it is in cascade, it is multiplying by multiplying these two. That is what is done. If it is a parallel, it will be P1 plus or minus P2. So we are adding here. So eliminating the feedback loop, P divided by 1 plus or minus, because it is minus plus, it will be plus or minus P1, P2. So this is what the condition. Then summing point, when you are moving the summing point is here. Now summing point is what is here? We are getting W plus X, W plus S. What is the condition here? We are only swapping. What are rearranging the summing points? So this and this can be swapped here. Just observe here, which was X, Y here, Y and X. Only we are swapping the position. That is also allowed. Rearranging the summing points is also done here. Just observe here the same thing. Now here also we can do, because anyhow we know that summing point is nothing but addition. Suppose there are two summing points like this. What we can do is I can get the summing point here, arrange like this, and write the same sign, because instead of putting here, I get the summing point here, as in this case, and maintain the same sign. So here it will be the sign here. Means what? Plus or minus, plus sign here, because it is why? Because the plus line is going here, and this plus or minus. So the same sign we are maintaining, and we are controlling this. Then moving a summing point ahead. So if you see the summing point ahead, if you do, so what we are doing here is, when we are taking here, we are allowed to multiply. When we are moving ahead beyond the block, we are going to multiply it. Then similarly, takeoff point, when we are taking point ahead of the block, so we are going to do, we are taking this, moving the takeoff point ahead of the block. So what we do is, here we multiply, and if we are doing takeoff point behind, we are going to divide. So we are going to divide this. So with this, whatever the basic rules are there that have been discussed, we'll be solving the problems now. So while solving the problems, anyhow, we'll be once again understanding the same rules. So what I'll do is I'll discuss few very simple problems today, so that you can understand. What I'll do is, before once the class is concluded, the same PPT will be shared with you, so that you can go with the rules. And tomorrow we'll go with slightly complicated problems. No. So today we'll be discussing regarding very simple problems. Now there is one thumb rule. There are few steps which are followed. The following general steps may be used as a basic approach in reduction of the complicated block. Means what? These are the following steps which you can follow in order to see that you can solve a complicated block diagram. So we'll not go with the will not go with the steps in the previous. We have taken down the steps here, so we'll discuss here. Now just observe here, and one thumb rule in case of solving block diagram is always go from inside to outside. Don't come from outside to inside. Means what? Don't start solving the block. Go on solving or reducing the block diagram from outside. Start from inside. You solve this, then solve outside. Don't start solving from outside. Start solving from inside. Now, suppose this is question here in this chapter. A question is asked: given a block diagram, reduce it to the simplest form and write the transfer function. This is a question which is asked for 10 marks. Now, suppose this is the block diagram which has been asked, and they have asked us to reduce. Colonial form is a simpler form. Colonial means nothing but a combined form of a very simple form. Now, this is the drawing which has been given, and we have to reduce it. So, in that condition, how we are going to answer? Just observe here. Now, just observe. If you can see this, can I apply the cascade form? Yes. So you can just observe when I can see this, as already know, I'll have to start from inside to outside. So what I'll do is I'll take this, I'll reduce this. So combine all the cascade blocks using transformation ones. Means what? I'll apply this first rule. I'll cascade this. So I'll write G1 into G2. I'll write G1 into G2. So I'll replace this block by one more block. That becomes another drawing. You are going to draw the one more drawing here and replace this by G1 and G1, G4. G1 and G4. That becomes your second drawing. Remember here one thing. Here, whatever drawing is given in the question, you'll have to initially draw whatever is given in the question paper. That becomes your initial drawing. Second drawing, whenever you are going to do, what you do is whichever part you are solving, as in this case, you are solving this, you can encircle this with the pencil. You can encircle with this pencil and draw one more drawing. Draw one more drawing with the solved one below. We'll have to draw this drawing which is solved one. As in this case, you are replacing this with G1 and G2. Sorry, G1 and G4. You'll have to draw one more drawing. All these things are there. Instead of two blocks, I will only replace with this block, that is G1 and G4. That becomes your second drawing. Then remaining things. So this first step is done. In second step, just observe this. G1, G3 and G4. Sorry, G3 and G2 are there. So as they are in parallel, can I write like this? G1 and G2. So I'll have one more drawing where I draw this summing point, I draw this summing point, and already have solved this. Don't try to combine 2 to 3 steps in a single drawing. Remember this. Each drawing, each block will have only one rule you are going to apply. We cannot write more than 2 to 3 rules in a single block. It is not allowed because it will increase the confusion. So always remember this. You solve one, you simplify one block, draw a simple drawing. You simplify one more block, draw the drawing, and then you can understand. So for this clarification, I'll just show you one image so that you'll understand how to do it. Then I'll come back to that drawing. So that just a second. Come back here. Now, see here. Suppose this is the drawing which is given to me. Suppose this is the drawing. Now just observe here. I'm reducing this block. So see here. So some modification I do. Which formulas I have applied, I'll just let you know here. Now just observe here. G1 and G2, they are in cascade. So that they are solved here. Now see here. This was one drawing. This was one drawing. After solving, now you just observe that G1 and G2, I can multiply. So what I do is, I replace this drawing, I draw one more drawing. So this drawing becomes, this drawing is the second block. Then what is to do? Then these summing points I can rearrange. That is what is here. So if you just observe here, this rearrangement, and this is a feedback loop that is shown here. G1, G2 is replaced. Now just observe here. These two are getting added. However, just here, because plus, 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 minus. If you just observe, plus, minus is already there, and that becomes feedback loop. This is now. Now once again, these two are in cascade. These two are in cascade. Here. This and this are in cascade. G1, G2, G3, G1, G2, G3 divided by 1 minus G1, G2, H1. That is solved here. G1, G2, G3. This is solved here. Now, once again, this is a feedback loop. Why? Because the signal is going here and there is one signal. So this two I'll solve as a feedback loop. I've solved it. Then you just observe here. these two. No, reason why I'm discussing here this problem is I'm going to revisit this problem once again. Only what I'm discussing is, in case of solving the block diagram, whenever you take any two blocks, and if you find that any rule I can apply, that is maybe cascade or parallel, you solve only that and represent one more block where you have simplified that. Don't try to club all the steps in a single. That is the reason why I'm solving this. I am going to revisit this problem once again, but the reason why I've told is, reason why I told this was, here you are not supposed to combine all the steps and show in a single block. You are out to suppose simplify one and only draw the drawing. Because it is of 10 marks, you cannot simplify everything and show it in a single block. That is the basic idea. Got it? Have you understood this? Any doubts? Any doubts? So here, as in this case, G1 and G4 has been replaced. So you draw one more drawing. One more drawing you draw where this G3 and G2 are there. So that you are replacing by one more block. Why? It is G1 plus G2. Then one more thing, you can just see here, G1, G4 and H1 is a feedback. G1, G4, G4, this is the feedback. This is already available. So that you are shown here. Just observe here. This G1, G4 and H1, that you are written G1, G4 divided by 1 minus, because it is plus positive here, 1 minus G1, G4, H1. G1, G4, H1. So all the three things are there here. This is written here. Then the drawing which was here, that is, this drawing was replaced by what? This drawing was replaced by G2, G3. G2, G3 is here. So this block is written here. This block is written here. Now, how we can do is this, for these two, again, you apply the cascading. If you apply the cascading, what I'm going to get? G1, G2 into G2 plus G3, G1, G4, G1, G4 into G2 plus G3, whole divided by 1 minus G1, G4, H1, that you are written here. Then for this block, again, we can apply what? We can apply the block diagram or feedback reduction. That is G1, this block divided by 1 plus this block into H2. That is written here. That is what is written. Is it understood? Is there any confusion? Yes, please feel free to ask the doubts. Don't carry the doubts to the next class. If you have any doubts, feel free to ask. Get it clarified as today. That is so that you will not carry the doubts back. Yes, any doubts are there, please let me know. If you have any doubts, if there anything which is not understood, I'll explain it. Feel free to ask. Yes, any doubts? Sriran, can you tell me which step you are asking? Last step means which one?
So,
Sriran,
step 6.
which one?
6.
Step number 6 is not there, because here in this problem, step number 6 is not there. Okay, I'll just repeat this problem. See here for this. See here, given this block diagram, what I will do is, I'll initially only solve this. Yes, any Sriran, can you repeat? Srirang Sudhar. I'll just repeat this problem for everybody's benefit. Now, see here, this is. Tell me.
Yes, sir. Hi, sir. Hi,
this,
sir.
This one, should I explain this once again? Every problem? Hello?
Yes, sir. Yes, sir.
Okay, I'll just explain. See here. Now, this block diagram is given. I want to solve it. So, don't get confused or don't get scared by observing this. Always remember, I'm going to solve it from inside to outside. Inside to outside, I'm going to start. So, I'll just observe this. So, once I observe this, I can see that G1 and G4 are the two things which can be getting cascaded. So, what I'll do is, I'll cascade this. So, I'll multiply this. I replace this by G1 and G4. So, I replace this by this. So, one more drawing I'll draw. And in this case, I'll write G1 and G4. Then once this G4 and G4, then I'll go to next part. Then I can just see here, G2 and G3 are in parallel. So what I'll do is I'll simplify this and I'll write G1 plus G2, G2 plus G3, G2 plus G3. I'll just, because they are in parallel form, I'll replace this. So I'll replace this block by G2 plus G3. Then once this is done, then I have observed that this G1 and G4 which was there, that and this H1, they are in feedback loop. So this is a feedback loop. So what I'll do is I'll just solve that also. So G1 into G4 divided by 1 minus H1 G1 G4, that you have done here. That is G1 G4 divided by 1 minus G1 G4 into H1. This you have done. So the part which was much complex, so this is reduced by cascading, this is reduced by parallel flow. Now this entire thing is been reduced by feedback. So what I'll have 1, 2. I have 1 and 2.
Hello,
No,
hello, sir.
tell me.
Sir, in step 3, there are the in
Tell me.
step 3, sir.
Ah.
So sign is in 1 minus G1 G4 into
Huh.
H1.
Huh.
It should be plus or minus, sir.
No. What I've said, I'll just repeat. In case, because it is a feedback loop. Is it in the case of feedback loop? Because why? There is a sign which is coming back. The signal is coming back. So this becomes a feedback loop. So this can be simplified by writing this form: G1 G4. That is the transfer function of this divided by one opposite sign of this. One opposite sign, that is, if it is positive, I write negative. If it is negative, I write positive. Now just observe this and this. Just observe, try to this. Observe step number 3 and step number 5. Step number 3 and step number 5. Now, in this case, step number 3, this is positive here, so I'm written negative here. And in case of step number 5, this is positive here, I have written, sorry, this is negative here, I have written positive. So whenever there's a positive sign here, in the opposite will be this. If it is a negative sign here, opposite will be this. So just observe, this divided by one opposite of this into this into this. So here it will be G1 G4 divided by 1 minus G1 G4 into H1. That is written here. Is it clear?
Yeah, yes, sir.
Okay. Then once again, I'll just observe that these two are in parallel. So once again, I'll multiply this. So I have multiplied this G1 G4 divided into G2 G3 divided by 1 minus G4 G1 into H1. Now once again, if you just observe, this is a feedback loop. So this part, this feedback loop divided by 1 plus this into H2. Is it clear? Is it done? Is it understood? Yes, any doubts? Yes, any doubts are there? Yes, any doubts are there? Let me know, or else we'll go.
So one more time that about the
Which one? Tell me, Rahul.
so about that H2 feedback, sir. Last one.
Feedback. See here, it is very simple. This we have understood, no? Pavaskar, Neeraj.
Yes, sir.
This you understood. This because these two are in series, we will to multiply. That is multiplied here. So final answer C by R is equal to this entire part divided by this entire part has to be taken. This entire part divided by one opposite sign of this. That is 1 plus this into this. Is it clear?
Yes, sir. Yes, sir.
Now remember, sometimes what happens is this becomes very huge, maybe around 10, 8, 15 terms are there. In that condition, what you do is this you write somewhere, note this is equal to X or maybe Y. Got it? Because sometimes it becomes maybe G1, G5, G7, G8, so many terms are there. This becomes very huge term. In that condition, what you write, note this is equal to X. Then in that condition, what you can write, X divided by 1 plus H2 into X.
Yes,
Got
sir.
it? This is what you write. You write this as X. X is equal to this. So you can write C divided by R. That is C divided by R is equal to X divided by 1 plus X into H2. That you can write as answer. Got it?
Yes, sir. Yes, sir.
Then once after everything is done, finally you can write hence the answer is equal to C divided by R is equal to, then instead of that X, you replace this value and conclude in the final form. Because sometimes some examiner do not find that method is correct. Got it? But sometimes, since it is very confusing to write this in block and space is very constrained, in that condition you can use that method. Is it clear?
Yes, sir.
Okay. Anybody has another notes? Rahul had, I think Rahul had some doubts. Rahul, is it clear?
No, sir.
Okay, is it clear? Okay. Any other doubts? Anybody?
Sir,
Tell me, Rahul.
sir, I wanted to ask for this first unit, which textbook to refer?
Yes, Russell. For any textbook, I think once I had sent some soft copy. I think they have put it in your group. Just observe, or else I can, because here what happens is, because of this intellectual property right, we are unable to give the soft copy of any textbook through Google form. If anybody is coming to college, I can give that book to you as a soft copy, but we cannot put the soft copy in Google Meet because it becomes an official document and infringement of rights are there. So they have asked us not to put any soft copy textbook in Google Meet or Classroom because it is official part. Got it? So what you can do is, if anybody is coming to college, soft copies is there in my PC, I can give it.
Okay, so I'll come to college now.
No, okay, no problem.
So after
You can come tomorrow because that copy is in my in-house. I'll get it today. So I'll just share it by to you.
Okay, okay, sir.
Harsh had put that. Can you put it through WhatsApp? There was some problem with some student, but because the book is slightly larger, means the data is big. So I'll give the copy through this soft copy only. Okay. See, this PPT I'll share with you today. Got it? I want everybody to just practice these rules because tomorrow we'll be discussing some problems. And during that time, these rules are very much necessary. Got it? So I'll just share this PPT in the class and you can go ahead. And regarding this assignment, I have valued your assignment and most of them have done well. Some students, I don't know, maybe they have not read the question carefully, where we had not asked any kind of analogy, that is force voltage or force current analogy was not asked. Maybe somebody has solved it and that got circulated and everybody has solved it. Maybe don't know. So the same answer were found to most of the cases, and we could see that pattern. Very few have gone through that force voltage. Remaining those who have only done normally process, they have got full. And some where they have gone for force voltage and force current analogy, they have not done that. So correspondingly marks have been given. Regarding this School of Mechanical Engineering GIT Telegram group. Okay, I'll just share that through. I'll just share. Okay, no problem. I'll just share. Okay. Any other doubts are there, or else I will conclude the class.
Sure.
Yes, tell me.
So I wanted to ask about the notes, sir. Since I is close, sir. Sir, if you can provide us notes according to the syllabus copy, sir, in a sequence, sir, it would be very helpful.
No, what I have made sure is, while preparing PPT, I have made sure that all the parts, whatever are in the textbook, are put on the PPT. Got it?
Then, sir, it is easy to refer it, sir, but if you want to learn from it, it is very difficult, sir.
PPT, and I'll share the textbooks, because what I do is, I don't refer one or other textbooks for this. I refer more 3-4 textbooks. Writing notes will also become slightly difficult. What I'll do is I'll share the books with you. PPT is there. You go through this. Any moment if you find any difficulty, you let me know. Got it? Understood.
So I was asking this because, sir, we don't have textbooks.
No, textbook.
It is very difficult to.
Textbook today, whatever possible, I'll just share that soft copy textbooks are there with you. Got it? One book I have got, one textbook is there. I'll share that copy with you today. Got it? You just go through that textbook. After that textbook, PPT is also there. You go through both. Further, even if after that, if you find difficulty, let me know. I'll solve that problem. Got it?
So what is the name of the textbook?
Which Nagarat Gopal is one, and one more textbook is there, which is a VT version, that is called as Halesh. That book is there. I think somebody I'd shared it in a group, man. I don't know how that. I had asked one student. I don't remember the name. I had shared with him. I'll just share 1 minute. I had sent that copy to him. I had sent that copy to him, textbook. How that fellow has not done. No, what I'll do is just here. Shubham Birje. Shubham Birje was one student. He had taken that book through me. If somebody can give me his email ID, I'll just Harsh, you can just give me your email ID, or somebody whose email ID is very easy. I'll just send this copy. You can Mohammed, otherwise you only give your email ID. Okay. harshpujari@outlook.com. Okay. See, Upendra is told, see, it is there in the United group. Okay. Harsh, just check out whether you have received that copy. I have mailed it.
Sir, are these books available in the library?
Which book, whichever I have sent, it is not available. Which I have sent, no, it is not available. Other books are there in the library. That is, Nagarat Gopal is available. That book is there, which is available in the library.
Okay, sir.
Which book I have sent, no, that is not available.
Sir, if possible, sir, you send your notes, sir, because it will be easy to refer, sir.
Okay.
So just the numerical, sir.
Numerical, whatever book I have just sent, Sufyan, I have sent which book, no. In that problems are very, you can easily solve. And one more book is there in the library. You can come down, anybody. I'll just share that copy. It is a book by Ganesh Rao, which is called as Ganesh Rao, book in Ganesh Rao. It is there in syllabus copy. Large number of books are available in our, and that book is not available in mechanical section. It is available in electronic section, because this is subject for electronics also. No? That book is available in electronic section. Book by Ganesh Rao. That is also very good. Just Sufyan, just check whether you have received it. Harsh Pujari had sent me.
Sir, received, sir.
No? You just put that in your unofficial group or whatever. Try to put it in unofficial group. Just share that.
Yes,
So that I'll just can just go through that book. Got it. Here for problem solving and all, it is very good book. You have all the data. Got it. Theory is also clearly written for your this. Refer the PPT. What I have done is, for preparing the PPTs, I have referred very standard books for this. After that, even after that, if you find any difficulty, you let me know. I'll give that point. Because what usually we do, we refer to the textbooks and solve it. Or do not combine in a single form. Writing also becomes that habit also we have slightly lost. But let me know. If any difficulties, let me know. Any problems here? Any problem while solving, if you find it difficult, you can just put that in this. Will give me a day. If it is possible at that time, I'll solve all this. I'll put the solution in the next class. Anyhow, okay. So with this, I'll conclude today's class. Thank you.
Thank you, sir.
Thank you, sir.